Alright, we're going to start off from where we left off last time, but this time we're going to make a different game, a different kind of guessing game called Bulls and Cows. And actually this is a game that I hadn't even heard of until quite recently. And so yeah, we're going to start off from where we left off in the extras video, which had a little bit of extra code for the errors. If you're interested, go ahead and check that out. I'll put it in the eye. So first thing we're going to do is I'm actually going to, if you recall, I told you that init, as opposed to initialize, but init is a special keyword. And so what we're going to do is we're going to take initialize out, and we're going to switch this initialize function into an init function. So it doesn't have to be at the beginning, but I like to put them at the beginning. So I'm going to move it to the beginning and just rename it to init. And it should work exactly the same, except we don't actually have to call it. What's happening is it's getting called as soon as this package gets loaded. So go run bulls and cows, and you see that foreground 1. You'll see that it still does both of our print screens, and in the background and then it's also seeding our random and setting up our reader, so everything works exactly the same. But we're not gonna actually finish that. And here, undo, get that full screen again. All right, so there's our initialize done. So the basic premise of this game is that instead of you trying to guess a random number, you're trying to guess a random word from a bank of words. So let's go ahead and make a bank of words. So one thing we haven't talked about yet is what's called a slice. In other languages, it's called an array. And actually, there's an array in this, but it's implemented slightly differently. And anyways, this is a slice. So we're going to say words. We're going to set up a variable called words at global space, and we're going to set it equal to a slice of strings. And then we're going to initialize it with our list of words. So we'll do cat, dog, gopher, since we're doing go, and apple, whale. Sure, why not? Oop. Alright, so now we have a slice of words. And what we can actually do with slices, one of the things we can do is get the len or length of it. So we could do len words, and that actually is going to return back to us the length of that slice. So what we're going to do is we're going to find a random one of these words. So in order to do that, though, we need to find a random integer between 0 and the length of words. So we'll replace that 100 with this length of words. And that'll actually give us the word. And that's actually going to give us an index. And the way... So a slice, you can imagine it as taking whenever it's allocated, it goes ahead and sets aside a whole bunch of chunks of memory in a row. And then when you put values in it, it is actually putting those values into those chunks of memory. Now, the number of chunks of memory that it's going to allocate is its capacity. Slices in Go are immutable by nature, but you can append to them, and you can, you know, send them into functions. But what's actually happening in the background is it's actually allocating another slice of whatever capacity and doing the work into that slice. So anyways, all that to say, that is our chunk of memory that has all of our words in it. Now, to access each one of those words individually, we would do words and then use the square brackets with whichever one of those were with an integer value that would correspond to the place in this list that would correspond with the word that we cared about. So, for instance, cat, in programming languages, we always, or generally most of them, start with 0 when you're indexing. That indexing is what it's called when you use an index to access something inside of a slice. So it starts with 0, and then dog would be 1, and then gopher would be 2, and then apple would be 3, and then whale would be 4. So we're getting a random one of these. The length of this would be 5, because there are 5 things in it. So since we're getting a random integer that starts at 0 and goes all the way up to, but not including 5, this is perfect. So that random index will give us a random word that we can then print line the word. And we're just going to do this for now. Down here where it actually talks about the number, we're going to use the word. But we're also going to just comment this out for right now, because we're going to come back to that. Oop. So in order to do a block comment, you do the /*, and then at the end of it you do //, and that ends the... So all of that is commented out now. So let's move over to our shell and just make sure that it's finding a random word for us. And it's not. As declared and not used. Oh. Okay, so this is because we are doing... I didn't comment enough out. So I'm going to switch back over and comment the rest of this out because we don't care about it right now. And it's going to actually just print out that stuff and then exit immediately, which is kind of perfect in this case. So now we've got an error that says non-declaration statement outside of function body 42. So let's go to 42. See what's at 42. 40. Oh, yeah. Since I moved the block that we're commenting out, I needed to get that bracket as well, that curly bracket as well. So one more time. There it goes. Okay, so it got a random word. Let's make sure that it's different next time. The same. All right, there we go. Just had really good luck getting dog that time. Dog seems to be the trend. All right. I'm satisfied that we're getting a random word. So let's go in here and actually start re-implementing the rest of this, or modifying it how we need to. So first of all, since we're getting a word this time, we don't, let's start out by changing our print up here. And actually, we're just going to take this line out because we want to say something different. And we won't know we won't know what we want to print is we want to give them a hint in the length of the word. So guess a word of length. I know how to spell, I promise. There we go. And then we use D because it's a digit, and then we're not putting a new line here on purpose, and then we give it the len of the word, not words, but the word that gets picked. So the word is a string, and len not only works on slices, it also works on strings. So it'll give us the number of letters in our string, i.e. our word. And then it'll print it out. And so our input this time is not going to be a number, it's actually going to be a string. So let's switch I to str. We don't need this special case for the error. If we get an error, we just want it to return. We want to give UN the word and the string. And alright, let's go down here and change UN to take in strings and change this to stir instead of I. And let's actually not do stir. Let's do guess. Make this a little more, and we'll change the number to the winner. So then we can change if guess equals the winner, and then we'll take this out and not winner. We'll do that for now, and we're gonna get back a string instead of an integer. And instead of doing we're not returning integer, we're returning a string, so let's do an empty string right there. And we're not doing any of this conversion stuff, so we're just returning back the string that we get. Simple enough. So that should put us into a never-ending loop until we happen to guess the number correctly. Let's go ahead and try that. Alright, we have two imports that we're no longer using, so let's comment those out because we might use them later. Actually, we're not going to use string conversion later, we will use strings later. Alright, so it's told us the answer, which is gopher. Let's try something different, just not a winner. Alright, so let's try gopher. That's not a winner either. Well, the reason for that is because, if you recall, when we get the user input using read string with a new line character at the end, it actually returns us the string up to and including that new line. So we're actually getting the word plus a new line. So what we actually need to do is, when we're sending it into UN, let's say strings trim space, and send that in instead. And I need to go back up and re-add strings. Let's try it this time. Kill that. Alright, gopher, not winning there. Gopher, win. Alright, perfect. So we have our win condition. But if they don't, the whole point is to have a whole bunch of words and to help them to figure out what the word is, not have them memorize all of the 6-letter words, right? So the way that works is actually where the bulls and cows comes in. So they get a bull for every letter that is the right letter in the right place, and they get a cow for every letter that is the right letter but in the wrong place. So how can we do that? So we're going to go down to our when, which is where we check for when conditions. And we're actually going to copy this line because we're going to need it here in a second. And So in this else, if we are not a winner, then if the length of the winner, and if they don't even guess a word of the right length, we want to remind them what the length is. So if the length of the winner is not equal to the length of guess, then we want to print that same statement so that we can remind them of the length of the word, and then it'll move on to the next guess for them. So if they are the right length, let's just go ahead and take this out. That's not intended. Oh, we'll get there. All right, so now this is where we're actually going to be counting our bulls and our cows. So let's go ahead and set up two local variables, one for bulls and one for cows. And actually, we're going to use something kind of cool that's part of Go. So we're actually going to set both of them, initialize and create, allocate and create them both in the same line by putting both of them separated by a comma, allocate equals, and then the two values separated by a comma. So it's almost identical to the way that we can send out multiple return values, except it's just with a creation or setting equal. It would also work if we did already had them allocated but wanted to like reset both of them for some reason or another. All right, so the next thing is we need to actually go through and check every character, every individual letter or symbol in our guess string, right? So that we can figure out whether it's a bull or a cow or nothing at all. So the way that you do a for loop that's actually looping through something instead of just an infinite for loop like we have up here is there's actually several ways, but the way that we're gonna use because it's much more idiomatic for Go is for, and then you give an index, or you give a variable name for the index, and then comma, and then a variable name for the what's actually stored in that at that index in whatever you're looping through. And this works for maps as well, but we'll get into that later. And so we're going to use C for character, and then we're setting those equal to the range going over the guess. And so what this is going to do, since guess is a string, is actually going to go through and for every single character in string, it's going to give us the index and the character. And let us loop through each individual symbol in guess. Here, real quick, let's look at that real quick. So let's go to GoLang and documents and language specifications, and then if we go down here to statements, there's the for statement, and this shows you this is not super easy to read like just in this format, but if you go to each one of these, it'll kind of break it down for you. So here is the range clause, or the for range, and down here we see where it's talking about with the range what the first value and the second value that it returns are, this I and this C, right? So if we go down here to string, we'll see that, all right, the first one is an I for an integer, which is the index, and then the second value is actually not a character or a byte, it's actually a rune. And the reason for that is because it is it's Unicode safe. So that means that we have to take into account Unicode. Now I can go ahead and tell you that when you reference a string, for instance, say we did guess I, like we were doing, just like you can use length on a string, you can also use the accessor brackets on a string, and that'll give you an individual byte in that string. Now, a byte in the string is going to be different than a rune in the string, because the rune is actually going to take into account if it actually takes up multiple bytes because of Unicode. So we can't actually do this. What we have to do instead is, let's go back a couple levels, back to packages. We have to go into Unicode and use something from there. So there's a package for GoLang called UTF-8, and that's the Unicode that we want to use. And if you notice, there's a decode rune in string, and it's going to give us, and it takes, excuse me, it's going to return a rune and a size, but it takes a string. And what's actually going to happen is it's going to return the first rune that it finds in that string. So, and that's what we want is, we want to check the winning string for if the rune in this same index is the same, right? So we don't care about the size, we just care about the rune. So we're going to go ahead and UTF-8, and we're using decode rune in string, and then we're gonna give it the winner. And another cool thing that you can do with slices is you can actually make a subslice by saying where you want it to start, and then giving a colon, and then telling it where you want the subslice or the substring or the subslice that you want. And in a string, it's a substring there. But if you leave it blank, then it just assumes the end. So it'll say starting from I, which is where we are in the other, in guess, starting from there, going all the way to the end, I want you to find the first rune that you come across. And it's going to set it equal to win rune. So then we'll say if C is equal to win rune, because that's what we care about, then bulls gets incremented by 1, and else if, and we're going to use strings again. If you, real quick, first of all, we need, for the import of this, we need to import Unicode UTF-8. So I'm actually just going to copy that so that I don't have to remember how to spell things, and paste it. All right. So the other thing is, if you had watched the extras, you would know about the strings contains function. We're going to use something kind of like that to check if, I forgot to, I also need to have a opener. There we go. So in the strings package, we have the contains function where we give it a string and a substring, and it tells us whether or not that first string contains the substring. Well, since we're dealing with runes, we need to use contains rune instead. So we'll do contains, because now we're working on cows. We want to know if it just simply contains the rune, and it was contains rune, right? Yes, perfect. And we'll give it the winner and the C, which is our rune that we're checking right now. And if that's the case, then it's
cows
plus equals 1. And then at the end of this chunk, so up here, if the length is different, then we print that. If the length isn't different, but again, we're not a winner, we check for winner up here, right? That's where we want to buck out immediately if that's the case. So we check that first, and then if that's not the case, that's when we go through here with our game logic, right? So if the length's not the same, then we want to print this. Well, if the length is the same, what we actually want to print is the number of bulls and cows. So making sure that we're still inside the same else statement, we're going to print, formatted print, that we have bulls, this many bulls, and this many cows. Oop. And then ask them for another guess. And again, we're not going to do a return because we want them to actually put their input right here, right? So then we need to actually feed the value. Oop, forgot a percent. We need to actually feed the values into there. So we have bulls and cows. And hopefully that's it. So let's switch over to our shell and actually try and play this. We may be done. Oh, undefined the word. All right, so that's at 49. So let's go to 49. Oh, right, because it's the winner that we wanted to check, not the word, because I copy and pasted. And then the other thing was at 63. Oh, we're not returning. Yep, need to return. That's no good. All right, so we'll just return false in this else, because no matter what, all of these did not win. So we don't care about returning inside of there. We just fall through to this false, this return of false. All right, so let's try that one more time. All right, want to play a game? Guess a word of length 6. And we told ourselves what it is, but let's, you know, for the sake of, let's try dog. No, it's 6. It's 6 characters. What are you doing? So let's try go E-E-E-R-E. Theoretically, that'll be 1 bull and 5 cows. And that's exactly what it is. And we'll do go and that's 5 and 0 cows. Let's try all cows and no bulls. So let's go O G G G G G. So that should be 0 and 6. It is. And then let's do our win condition. There we go. We got a full game. All right. So let's go take that print statement out so that we're not telling them what the answer is every time. And then we're good to go. That's it. So that's it for this one. Next time, we're going to talk about actually not hard coding this list in here so that you can have, so that you can not have this in your code if you want to. You can have it in an external file, and B, so that you can pull it from an external source if you want. And then the one after that, we might get into, like, say, pulling that from a server. So look forward to that. I'll see you guys next time.